In this lecture, we're going to look at some of the consequences of use of energy in the muscle cell. And so we'll be discussing oxygen debt. So what happens when we run out of sufficient oxygen to do aerobic respiration and have to go into anaerobic respiration. We'll look at fatigue. So what happens is we use up available energy in a muscle cell, and also at heat production. So we'll start with oxygen debt. So when a muscle has finished its work and is now returning to a resting status, there's work that still has to be done to bring that cell back into a resting state. First, because we've had to use oxygen as the muscle was working, we have to restore the oxygen supplies that are in the cell. So there's oxygen reserves of just oxygen dissolved in the cytosol, and if we've gone into the myoglobin stores, then we have to restore the oxygen back to the myoglobin stores as well. If we had to go into anaerobic respiration and there's been production of lactic acid, remember that was the side product of doing respiration without oxygen, where we only got 2 ATP molecules out of the oxygen and a lot of lactic acid was produced. Well, all that lactic acid has to be returned to the liver, and it can be converted back into glucose. Now that also requires ATP to do, as you recall, but with a little ATP, we can take all of that lactic acid that wasn't fully metabolized and restore glucose so that we can still get energy from those molecules. We also have to refill the cell with glycogen. So remember, we've used glucose in the cell, and so the glycogen stores got tapped into, and we have to bring into the cell more glucose and then tuck it away as glycogen. And then finally, the energy reserves of ATP in the cell and the creatine phosphate that was there to make ATP so that we could rapidly produce additional ATP. We have to replace all that used ATP and the creatine phosphate stores that have been depleted. All of these processes, every one of these, requires oxygen to do in order to accomplish all that. And so in order to bring the cell back to its resting state, we have to get oxygen delivered to the cell or delivered to other parts of the body in order to restore that resting state, to restore homeostasis around all of the issues that occurred when we ran out of oxygen or sufficient oxygen in the body to do everything by aerobic respiration. So we describe that as oxygen debt. The oxygen that has to be still brought in, even after we've finished work, it still has to be brought in to restore homeostasis. So that amount, that oxygen debt, represents the amount of oxygen that would have been needed if all the ATP that had been produced in the muscle had been provided through aerobic respiration rather than anaerobic respiration that occurred. And any oxygen has to be, this oxygen has to be taken in and then used to restore homeostasis. So one way to know that a body is still paying back, quote unquote, paying back, or in the process of restoring homeostasis, one way to know that the body is in that condition is when the person is still breathing heavily and attempting to get additional oxygen, like this guy here, attempting to get oxygen back into the body to repay the oxygen debt. Fatigue is a little bit, it is kind of similar to oxygen debt, but it's a state in the muscle where the muscle has used up all of, or has created conditions in the muscle cell where it is unable to contract anymore. Frequently, this muscle fatigue that athletes especially experience, but anybody who is doing some sort of heavy exercise or making use of muscles in a way that the muscles are unused to being used, if that makes sense. So if there is not sufficient ATP or whatever, we will send the cell and eventually the whole muscle into what's known as muscle fatigue. And the proximal cause, the sort of the root cause of this, is usually the accumulation of lactic acid that has been produced during anaerobic respiration. And as the pH in the muscle, because lactic acid is acidic, as the name would suggest, and so if there's a lot of lactic acid running around, then it's going to be a relatively low pH environment. And so as the pH of the interior of the cell, the cytosol, becomes lower and lower, eventually the muscle fibers are either will become incapable of responding to the nervous stimulation with a contraction. So the contraction is blocked because of this low pH environment. So all those ionic processes that are, the ionic movement of ions, that's what I'm trying to say, all that movement of ions becomes harder and harder to accomplish as the pH of the cell becomes lower. As we remove lactic acid from the cell and convert it back into glucose there at the liver, then the appropriate pH is restored and the muscle can resume function. But, so the lowering of the pH as the body becomes, as the muscle cell moves away from homeostasis around pH is one cause of muscle fatigue. But it can also occur as the result of the depletion of ATP reserves in the cell. And as the cell becomes less and less able to meet its ATP requirements, then the muscle can also go into fatigue, and contractions become challenged. It becomes difficult to produce a good contraction because there isn't sufficient ATP to do so. So two ways that muscle fatigue can occur. One is because of pH decrease due to the accumulation of lactic acid. The other is because we run out of ATP reserves and we can't produce ATP quickly enough to be able to allow us to power the muscle. Okay, so a third condition associated with muscle non-function is a muscle cramp. And these are sustained and usually painful involuntary contractions of a muscle cell, or of a whole muscle. Actually, it's when a whole muscle comes into that cramped state. And it's usually the result of ionic imbalances in the body. And it calls for this inappropriate balancing of ions will cause an inappropriate signal for contraction to be sent. So two kinds of ionic imbalances that can lead to this kind of cramping. One is hypokalemia. Hypo means low. Kalemia is a reference to the ion, the potassium ion. So that K is the root of the reason that potassium has K as its symbol is this term kalemia. So hypokalemia is insufficient supply of potassium to help the muscle cell do the contraction. Hypernatremia, hyper means excess amount of, and natrium is the old school term for sodium. So hypernatremia is having too much sodium associated with the cell. And both of these conditions can lead to, cramping. So with sufficient ATP restored to the muscle, then we can see that then that can help to restore these ionic balances, getting the potassium and the sodium to the appropriate sides of the cell membrane with enough ATP to be able to pump. What we have to turn on is the sodium-potassium pump using ATP. So A plus potassium pump can restore the appropriate levels of sodium and potassium. So we can restore those sodium and potassium balances. Or the consumption of foods that are high in potassium can also help to restore the balances. And so that's why we often think as a method of forestalling or putting off any cramping is to eat a high potassium food, like bananas are frequently suggested as a way to help prevent cramps from occurring. And last of all, a consequence of all this ATP production is heat production. So if you think about the amount of energy that's found in glucose, only about 40% of that energy is converted into ATP. The process is somewhat inefficient, and all of the remaining energy, about 60% of it, I say all, most of that remaining energy is lost from the body, and most of it is lost in the form of heat. And so we have homeostatic mechanisms that will deal with with shedding the body of all that excess heat. The first is that the blood will transport the heat throughout the body, so that we can even out the cool and the warm spots and maintain an appropriate thermal homeostasis. The second is that we will shed much of the excess heat to the environment, or we shed all of it. We get rid of that excess heat by shedding it out to the environment. So because of the large amount of our body mass that is built of skeletal muscle, and because of all the ATP that's consumed there by all that skeletal muscle, then the skeletal muscles are the primary heat producer in our bodies. The next one in line would be the liver, that also, because of its high usages of ATP, also is another spot where a lot of the heat is produced. But the primary heat producer is skeletal muscle. Okay, that's everything for this lecture. Any questions? Send me an email, give me a phone call. You know how to do all those things. And study well.